Well, it's my great pleasure today to the first after lunch session on Friday to introduce Neil Muller and supporting Python 3. Thank you.
All right. If I fall asleep halfway through this talk, that is not my fault. That is the fault of Hellfire, who provided very interesting drinks last night. So but I'm going to talk about supporting Python 3, and I'm specifically going to be talking about how you support both Python 2 and 3 in one code base, because that is actually quite a sensible thing to do. And there we go. So for people who've been around the Python 3 world with that, you'll recognize this advice. It was in the 3.2 docs, it was in the 3.3 docs, that the recommended way of supporting Python 3 was you ran 2 to 3 to convert your code, and you did this at install time for everyone who was using your package on Python 3. This is not a good idea. It really isn't a very good idea. You're adding a conversion step in, which means every time you're modifying your code and testing it, you also have to run this conversion. That gets tiresome, and you forget. It also introduces a disconnect between the code you're writing and the code that is actually being run. This is a pain when you're trying to work out why the code isn't working on Python 3, because the code that's actually being run doesn't look like the code you're writing, and now you have to go and spend 2 or 3 hours reading through the appropriate 2 to 3 fixes to work out what on earth is going on. If you've ever done this, you have my heartfelt sympathy. I've done it. It sucks. So don't do this. It is okay if you're going to completely abandon Python 2. If you can do this, I hate you with a passion, because most of us can't. So the current will is there are now good tools for supporting both 2 and 3. So use them. 6 is awesome. Honestly, it is fantastic, and if you ever want to feel really inadequate about your coding abilities, read the 6 source. 2 to 3 and related tools are great for identifying problems and bits that you will need to fix, but don't use those to fix the tools. Better tools are tools like Modernize or Futurize, which both try and convert your code to something that's compatible with 2 and 3. Which you use depends on quite what you're doing and your taste and, well, personal opinion. So what should you do? The first thing is you want good test coverage. Really, you want good test coverage when you're doing this. If you don't have good test coverage, go and write a whole bunch of tests. If you don't know how to write tests, get hold of Jeremy. He will tell you in great length how you should be writing tests, and then you can disagree with him widely about what to do. If you can, drop support for Python 2.5. It saves you a great deal of trouble. If you absolutely need to support Python 2.5, yes, you can. 6 will help you a lot. But honestly, 2.5 is old. There are people at this conference who probably haven't been writing Python as long as sort of 2.5 has been out. Really, why on earth do you still need to support Python 2.5? Drop it if you can. It's better if you can also drop support for 2.6. Just supporting 2.7 on Python 3 is much easier, but 2.6 onward is completely doable. There's obvious things. You clean up the Python -3 warnings. That just makes life easier for the other tools. Make liberal use of future imports, print function, absolute imports, Unicode literals, future division. These are all good ideas. It minimizes the differences between what's happening on 2 and 3 and makes your life easier. But honestly, if there's one takeaway from what I'm saying here, it's good test coverage. Do the mechanical work using the tools that do it. The module renames, import fixes, changes, such, they largely can be handled automatically. You may need to fiddle with the options a bit to get good results, but it's a once-off thing. Well, you do it a few times until you get good results, but then you've done it and you commit it and you forget about it. You never run the Transpile again. You use other tools and your tests to ensure you don't break things in the future. So the transpilers, the ones that recommended, Modernize, which uses lib2 to 3 fixes and adds a lot of dependencies on 6 to fix code that's not 2.3 compatible. It aims to support code that supports 2.6, 2.7, and 3.3 onwards. But rarely, there's no point in supporting 3.2, and no one cares. But 3.3 is quite bad, 3.4 is better, and so on. It can produce code without a dependency on 6 if you ask it to, but you get your best results if you just live with 6. And I already said 6 is fine. Futurize, think Modernize, but more with the Python 3 feel. It's part of the Future project, which is quite nifty. Future provides a whole lot of backport Python 3 features in a way that's Python 2 compatible. It's a much heavier dependency than 6, but the result is closer to Python 3 code. So now let's try and have an example. So here I have something that doesn't do anything particularly useful. It imports a couple of things that have been renamed. We create a stupid class that has a meta class because meta classes are things you do. We use reduce, we create that. That should not, because this is Python 2 code, that should not be doing that. We have an iterator. We do a couple of things with the iterator. We use an old style way of catching exceptions. We do an exec statement because that's changed. And we do a very large number, which comes to Python long, because we want that. This is Python 3, so I want to. If I run it on Python 2, it does various stuff and gives me output. And my screen doesn't quite understand that it's not the right size, so stuff keeps disappearing off the bottom. And I want to write that. And it prints out a whole lot of things and tells me what it's changed. So the thing is, it's added a couple of, this is Modernize, it's added a couple of future imports. The modules that's renamed, it's now importing from 6. Reduce is no longer built in, so it pulls it in from funcutools. It's replaced the metaclass definition with this 6 with metaclass decorator, which handles the difference between the way Python 2 defines metaclasses and Python 3 defines metaclasses. And it's done a few other changes. And it still produces exactly the same result on the Python 2. It doesn't quite work on the Python 3 because the conversion isn't perfect, because it hasn't properly fixed my iterator definition, but that's easy enough to do. Now it works under Python 3 and Python 2, and I had to make one change to the code, and the rest happened all automatically for me. And that was really not code that was written to be easy to, particularly good to convert to Python 3. We do a similar thing with Futurize, works much the same way. It's also got a similar sort of thing. The changes it makes are rather different, though. Instead of 6, we're now importing a bunch of stuff from the Future library, and so on. It's actually, rather than using 6 and using sort of similar names to the Python 2 ones, it's actually doing rewriting things, so it's now using the Python 3 names for the imports. It also has a with metaclass thing. You'll notice that it actually has fixed the iterator, which is quite nice. The other stuff is all very similar. And so we run it under okay, so this is a Python 3 virtual env with that. You see, now that works perfectly under Python 3 if I'm in a Python 3 environment which has Future. almost works under Python 2, except you'll notice it hasn't told me that what I've produced with a very long integer is a numeric type. And the reason for that is it has replaced my test for long and int with this, but it hasn't added that line, which I actually need. Now that works under Python 2, and still works fine under Python 3. So again, the conversion isn't completely perfect, but it's pretty good. Again, just one line I need to change. Yes, that's because Python 3 doesn't have a long thing. But if you're depending on that in anywhere in your code, you are doing it wrong. Honestly. It doesn't mean you aren't doing it, but you're doing it wrong, and don't do it. But that's just... So what we mean by so I've mentioned, but what we mean by futurize is more of a, gives more of a Python 3 feel. Oh no, that I need. So all of these things that's added are to support Python 2. The only thing that is not native Python 3 code is the with metaclass thing. And because that really is, the change in syntax is quite severe, and there really isn't a good way of doing that, having the Python 3 syntax work in Python 2. So futurize gives you something that is much more Python 3-ish. Modernize gives you something that's much more what you do if you do a manual conversion using 6. The conversion isn't perfect. There are a couple of small fixes you need to make. But really, the number of manual fixes you need to make is greatly reduced. I mean, I had to change one line in each of those things, as opposed to the tools doing 12 or 13 changes for me. So this gives you a lot of things. There are other tools which also help. I've mentioned the -3 flag. Running 2 to 3 itself can be useful for helping identify issues. Pylint now supports a whole lot of Python 3 checks, and if you get a sufficiently recent Pylint, you can run just the Python 3 checks, rather than having to deal with all of Pylint's opinions about how your code should look. Yeah, and so that is also very handy. But not everything is easy. Some bits still require some sort. And this is basically the text and bytes transition. You don't want to do this automatically because it's a bad idea to do this automatically because it does require thought. Remember how I said stress test coverage? This is why you want good test coverage. You do need to make API choices about text versus bytes. You need to think about this. You need to make sure you're doing the right thing for what your code is trying to do. People complain about this tremendously because it is painful and tedious and requires thought. But it actually is a really useful exercise to go through. If you've done this on a large code base, your code ends up a lot better. Explicit is better than implicit. And Python 2's the funky stuff it does with strings automatically implicitly becoming Unicode, that's not explicit. And so this is a really good process to go through, but the tools can help you and identify issues, but the tools don't know what your data is meant to be. Ideally, you do. If you don't, you're probably doing something wrong. So know your data. Marking all your string literals is a good idea. You can use the B prefix and Unicode literals from future, or U and B as you wish. But ultimately, it needs to be obvious whether the string is meant to be text or binary data, and that you can only do by going through the process. You need to update your APIs. If it's text data, works with Unicode. Binary data, works with bytes. Be strict about the distinction. One of the nice things about dropping Python 2.5 is you can now use bytes as an alias for string, so you can make things more explicit. Try and avoid actually using string in Python 2 code. The automatic upcasting does weird things. When you're dealing with the outside world, you want to try and convert between text and binary as close to the boundary as possible, so that for as much of your code you're working with the format you want to be working with. That's just standard good programming practice. There are a few common gotchas that hit you when you do this, When you index a bytes object in Python 3, you get an integer, not a byte, not another bytes object. You work around this by using slicing. But you know, it's just, the reasons for it are well documented, but is a bit surprising. There's one subtle thing that catches you out a few times. You know, Python 2 will happily compare a byte string with a strings object and do conversions for you automatically, which you don't really want because that's all implicit. Python 3 will generally give you a type error, except if you're doing equality comparison, when it won't, because equality must always return a result. And this can surprise you, especially when it's buried in a bunch of variables. I'll mention in a moment the sort of way of some tools to help you do that. The other thing you need to be very careful about is on a Python 2 object, you have a dunder Unicode method and a dunder string method. In Python 3, you just generally have the dunder string. And so this is not an uncommon pattern. I have an object which has Unicode data, I have a dunder Unicode method which just returns data, and I have dunder string method which returns an encoded version. You see this in wild quite commonly. If you do a simplistic port, in this case 2 to 3 is simplistic, can anyone guess what happens when I run string on an instance of object thing there? String, the str thing the str in str over here will call dunder str, which will call str, which will call dunder str, and, well, you will see that in other cases, but you end up with a recursion error. This is not what you want. So, you know, in cases like this, don't blindly trust what the tools give you, because sometimes they get it wrong. Use the available tools, though, to help you. 6 has some very nice helper methods, especially for dealing with cases like that, where you just define a dunder string method and it will handle the stuff that needs to happen for Python 2. Python 3 has this very nice -b flag, which will warn you of most of the common bytes errors. So things like indexing a bytes array, comparing a bytes array to a string, it'll give you that as a warning, and also warns you in a couple of other things. If you go -bb, it'll turn the warnings into errors, which can be very useful. And also on Python 2, -b is a no-op, so you can just blindly add this to your test suite and things will work, and then on Python 3 you'll pick up your errors. So, yeah, but the text byte separation is not something you can do automatically, but it's the major thing that requires work and thought, and there are a lot of benefits to it once you've gone through it. We've heard a bit about C extensions. If you're porting a C extension, you still have to work through the bytes Unicode distinction. Most of the other things aren't really significant. Porting a C extension is usually a bunch of little tedious fixes to deal with the fact that the API is slightly different, and a few FDFs and such. There aren't really great tools to help you with this, which is a bit annoying. There's very good documentation which tells you how to do it, which is really nice. But honestly, drop hand-rolled extensions. It's a pain even when you're not trying to port across multiple versions. They lead to all sorts of odd bugs. It's much better to use tools. You've got CFI, C-type, Cython. Boost Python has supported Python 3 since Boost 1.40, which I can't remember when it released, but it was a while ago. 1.40 and 1.41 were a bit flaky, but from 1.42 I haven't heard anyone ever complain about that. Swig supports Python 3 since about Swig 1.3, although 2.0 later is better for this. Cython produces code that's compatible with 2 to 3 automatically, if you like Cython. C-types and CFI both work on 2 and 3, although you do have to be, again, byte-string distinction you do have to be aware of, but that you're always going to have to be aware of. Honestly, if you're doing it, though, it's much better to use one of these tools, and if you're going to do it, have a look at CFFI. CFFI is really, really neat. It also gives you support from PyPy, which is quite fun. So, yeah, that's there. Yeah, basically, in conclusion, supporting 2 and 3 on a single code is not hard anymore. It requires a bit of effort. There's good documentation available. I have a few links. There are numerous others. Spend a few minutes on Google. You can find, thousands of lines written about Python, supporting Python 2 and 3. Yeah, it's really is a good thing. Python 3 is the future. Python 3 is growing all sorts of really nice features. It's useful to use. Python 2 will be around, but it's dead as a language. Should be looking to move to Python 3. So go forth, port code. It's educational, and it is actually quite fun. Thank you. Questions?
Thanks very much. Any questions for Neil?
So one of the sort of killer new features in Python 3 is the async IO, async defs, coroutines. Do you have any advice on how to support code that runs in both 2 and 3, but you can actually use a feature like that?
Okay, so 3.5's new syntax, that's tricky. There are, the async IO people do maintain a backport of the async IO library to Python 2. I don't really play much in the async space. It's not really well suited to the problems I'm trying to solve, so I haven't really done that much of it, but no, people use it. People seem happy enough with it. But it's not something that's completely trivial, because async IO kind of relies on a bunch of syntax changes in Python 3, and they're not really available in Python 2, so it's, things work just slightly differently in a couple of cases, but most of the time it works close enough. So I'd say have a look at the available backported library and use the native implementation if you on 3.4.
For us, a lot of the text we pass around in our application is actually computer-generated text for sensor values and things, and we're pretty sure it's all going to be ASCII. So if we're trying to support Python 2 and 3 in a single code base, would you recommend using the string type in both versions, or would you use Unicode?
The thing is, the question is, are you wanting to interpret it as text data, or are you wanting to interpret it as binary values?
Often we want to, it'll be a number, and we want to actually interpret it as a number eventually.
So, but it's a textual representation of a number.
Yeah.
So it's, then you probably want, the thing is, so the advantage of it, it's going to be ASCII is a subset of Unicode. So you can just, so it's a string in Python 3, it's a Unicode object in Python 2. You're not paying any space penalty, because the ASCII UTF-8 representation of the ASCII range is always going to be a single byte per character point. It's only when you start getting beyond the ASCII limitations that you start paying a space penalty for using a Unicode object. So I'd go with that route, because the point of the distinction is you want to distinguish between stuff where you're interested in the text representation, or where you're interested in this is just a buffer where I have values in it, which is binary buffer that something else will interpret. So if it's
and making that change, that's something one would have to roll out across sort of all the things you're working on, or
so there it's a matter of where you're interfacing with the outside world, or with other things. So you can make that's a bit of converting close to the boundaries.
Right. Yeah.
That you can make the change in one library and add appropriate conversion steps where you pass through.
Thanks.
And then when you replace do the next library, you can drop this conversion step and so on.
Any more questions for Neil? Well, Neil, thanks very much. Okay, appreciate it very much.